Okay, I just want to work a few examples to show you just how simple this formula is for the derivative of an exponential and also for the log. But let's start with an exponential. If you have a function like f of x equals e to, let's just make up a power, x squared plus 1. The derivative of an exponential is basically that same exponential. So the first thing you do is just copy down. It's just a copying process. You strictly copy what was the original exponential. Just copy it down. But then, that's this part of the rule. Then you multiply it by the derivative of whatever the exponent is. So you take the derivative of the exponent, which in this case would be 2x. And that's it. Now you can type it in like that in WebAssign. I don't know, WebAssign might ask you to put parentheses around the exponential. But basically you could type it in like that. My personal preference is to write the 2x first, but I don't think it really matters with WebAssign, although like I said, you might have to put in those parentheses. And unless it turns out that this exponential is part of a product rule or a quotient rule, just an exponential, an e raised to a power, that's all you do with the derivative. It's simply that simple. I mean, it's difficult to make it any harder. If you had f of x equal to, and if you have a number times any function, it doesn't have to be exponential. The number can just sit there and ride through the process. So if you want to take the derivative of 100 times e to a power, it would just be 100 times. And you use the derivative rule. The first thing you do is copy down the exponential, 3x squared minus x. And then you would multiply by the derivative of the exponent, which is 6x minus 1. And again, if you wanted to put this into WebAssign, I don't know, you can practice it. You might need to put parentheses around the exponential, or maybe you don't. I'm not absolutely certain, but you can practice that. And that's all you got to do. So these exponentials are very simple. Now they can make it a little more difficult if they embed it inside, say, for instance, a product rule or a quotient rule. So if you had something like f of x equal to x squared times the e to the, say, let's just make it simple, e to the x cubed. That would be a product rule. This would be like the u, and this would be like the v, and you'd use the product rule. The product rule says you take the first factor, which is the x squared, or the u, and multiply it by the derivative of the second factor. Well, the second factor is this exponential, and then you go back to your exponential rule up here, which says you copy it down, e to the x cubed, and then you multiply it by the derivative of the exponent, which is 3x squared. So this is like the u in the product rule. This is like the v prime. Then you add and you reverse it, and you write down the second factor, the v, which is just e to the x cubed, and then you multiply by the derivative of the u, which is the 2x. And again, WebAssign does not require much simplification, so I wouldn't do a whole lot here. You might want to take the 3x squared and multiply it by the x squared and get 3x to the fourth e to the x cubed, and then maybe slide the 2x in front in the second term. You don't have to do a whole lot of simplification. You can play around with it, but basically that would be the answer. So don't make these problems harder than they are. I'll go ahead and do a similar thing with the logs, but it's very similar. If I have f of x equal, say, the natural log of x squared plus 1. The derivative, if you look back, is always a fraction. I'm going to use this, u prime over u, that's the derivative. It's always a fraction. So the first thing you do when you're taking the derivative of a logarithm is just draw a fraction bar. Now notice in the formula, the denominator of the fraction bar is just the same thing that you're taking the log of. So what I'm taking the log of is the x squared plus 1, so I can just copy down the thing I'm taking the log of as the denominator of the final answer. So when you're first taking the derivative of a log, you write a fraction bar, you put the thing you're taking the log of in the denominator of the fraction, and then what does it say? Then it says to put in the numerator the derivative of what you just wrote down in the denominator. So I put up top 2x. And that's it. That's the answer. Don't make this harder than it really is. The derivative of a log of something is a fraction whose denominator is what you're taking the log of and whose numerator is the derivative of what you're taking the log of. Don't make this harder than it is. If you had the natural log of, I don't know, just do a simple 7x, a fraction, and in the denominator of the fraction is the thing you're taking the log of, and in the numerator is the derivative of what you're taking the log of. Well, what you're taking the log of is 7x, so the derivative is 7. And you could type that in. I'm almost certain WebAssign would take that as the answer. But you could also divide the 7's out and get 1 over x. Anyway, I could go on and on and on with these. The simple ones are ultimately so simple that you don't want to be missing those. I'll end with one more. Suppose I do a quotient rule. What if I have f of x is equal to log x, natural log of x over x to the 6th? That's a quotient rule. So it's going to be low d high minus high d low over low squared. So the derivative would be denominator, which is the low, x6, times the derivative of high. Remember, the derivative rule for the log says you write down a fraction, and in the numerator of the fraction, you write down what you're taking the log of. Well, we're taking the log of x. And in the numerator, we take the derivative of what we just wrote down. We wrote down an x, the derivative is 1. Derivative of natural log of x is 1. 1 over x, excuse me. Then minus, so we've got low d high minus high, which is the natural log of x, multiplied by the derivative of the low, which is the denominator. That would be 6x to the 5th. And then all of that is over the denominator squared. And you're going to have to do a little bit of simplification before you can type that into WebAssign, because WebAssign, I don't think, will do complex fractions. In other words, fractions inside of fractions. But what I do notice is that this x will go into that x to the 6th and leave an x to the 5th. So I'll end up with x to the 5th minus, and you can leave it written just like it is as long as you type it in parentheses. I'm just sort of old school about this. I like to put the polynomial part first. It'd be 6x to the 5th times the natural log of x. All over, when you raise a power to a power, you multiply, that's x to the 12th. You could probably get away with not simplifying nearly that much. You can practice it and see what it is that you want to do with it. But and you could keep simplifying this if you wanted to. I'm not. You could factor out an x to the 5th and cancel it out, but in the denominator. But WebAssign is perfectly happy with unsimplified answers as long as they're not too unsimplified. I do not think it will take a fraction inside of a fraction as an answer. But the point of this is the basic simple exponential logs are really that simple, and you don't need to make a big deal out of them. The derivative of log of something is the log of something just copied down, multiplied by the derivative of the exponent. The derivative of log of something is a fraction with that something in the denominator, and in the numerator is the derivative of what you just wrote down in the denominator. So that can get you through a whole lot of the problems.